The T-72 is a Soviet second-generation main battle tank that entered production in 1971. It was developed directly from Object 172, and shares parallel features with the T-64A. The T-72 was one of the most widely produced post-Euro World War II tanks, second only to the T-54 55th family. Origin: while the T-64 was perhaps the world's most advanced battle tank design when introduced, it was too expensive to issue to all the Soviet tank armies, let alone Warsaw Pact allies. Therefore the parallel development of a so-called mobilization model was ordered, while T-64 development and production continued. An economy tank with the old design V-46 powerplant was developed from 1967 at the Uralvagontsavod factory located in Nizhny Tagil. Chief engineer Leonid Kartsev created Object 172, the initial design, but the prototype, marked Object 172M, was refined and finished by Valery Venediktov. Field trials lasted from 1971 to 1973 and upon acceptance the Chelyabinsk tank factory immediately ceased T-55 and T-62 production to retool for the new T-72 tank. At least some technical documentation on the T-72 is known to have been passed to the CIA by the Polish Colonel Ryszard Kuklinski between 1971 and 1982. Production history: the T-72 was the most common tank used by the Warsaw Pact from the 1970s to the collapse of the Soviet Union. It was also exported to other countries, such as Finland, India, Iran, Iraq, Syria and Yugoslavia, as well as being copied elsewhere, both with and without licenses. Licensed versions of the T-72 were made in Poland and Czechoslovakia, for Warpac consumers. These tanks had better and more consistent quality of make but with inferior armor, lacking the resin-embedded ceramics layer inside the turret front and glacis armor, replaced with all steel. The Polish-made T-72G tanks also had thinner armor compared to Soviet Army standard. Before 1990, Soviet-made T-72 export versions were similarly downgraded for non-Warpac customers. Many parts and tools are not interchangeable between the Russian, Polish and Czechoslovakian versions, which caused logistical problems. Yugoslavia developed the T-72 into the more advanced M84, and sold hundreds of them around the world during the 1980s. The Iraqis called their T-72 copies the Lion of Babylon. These Iraqi tanks were assembled from spare parts sold to them by Russia as a means of evading the UN-imposed weapons embargo. More modern derivatives include the Polish .91 Twiddy. Several countries, including Russia and Ukraine, also offer modernization packages for older T-72s. Various versions of the T-72 have been in production for decades, and the specifications for its armor have changed considerably. Original T-72 tanks had homogeneous cast steel armor incorporating spaced armor technology and were moderately well protected by the standards of the early 1970s. In 1979, the Soviets began building T-72 modification with composite armor similar to the T-64 composite armor, in the front of the turret and the front of the hull. Late in the 1980s, T-72 tanks in Soviet inventory were fitted with reactive armor tiles. Laser rangefinders appear on T-72 tanks since 1978. Earlier examples were equipped with parallax optical rangefinders, which could not be used for distances under 1,000 meters. Some export versions of the T-72 lacked the laser rangefinder until 1985 or only the squadron and platoon commander tanks received them. After 1985, all newly made T-72s came with reactive armor as standard, the more powerful 840 bhp V-84 engine and an upgraded design main gun, which can fire guided anti-tank missiles from the barrel. With these developments the T-72 eventually became almost as powerful as the more expensive T-80 tank, but few of these late variants reached the economically ailing Warpac allies and foreign customers before the Soviet bloc fell apart in 1990. Since 2000, export vehicles have been offered with thermal imaging night vision gear of French manufacture as well. Depleted uranium armor-piercing ammunition for the 125mm gun has been manufactured in Russia in the form of the BM-32 projectile since around 1978, though it has never been deployed, and is less penetrating than the later tungsten BM-42 and the newer BM-42M. Models. Main models of the T-72, built in the Soviet Union and Russia. Command tanks have K added to their designation for Komandierski, a Euro Commander Euro unregistered trademark. For example, T-72K is the command version of the basic T-72. Versions with reactive armor have V added, for Vzrivnoy, a Euro explosive V, a Euro unregistered trademark. T-72 Ural, original version, armed with 125 ohm smoothbore tank gun and optical coincidence rangefinder. T-72A, added laser rangefinder and electronic fire control, turret front and top being heavily reinforced with composite armor, provisions for mounting reactive armor, smoke grenade launchers, flipper armor mount on front mud guards, internal changes. T-72M, export monkey model version, similar to T-72A but lacking composite armor and with downgraded weapon systems, such as a lack of fire control systems. Also built in Poland and former Czechoslovakia, T-72 SIM-1, increased implementation of K-1 reactive and K-5 passive armor. New Falcon command and control system, GPS navigation system and Polish SK-01T Drawa T fire control system with thermal imager and laser rangefinder. It has also a friend or foe recognition system. T-72B, new main gun, stabilizer, sights, and fire control, capable of firing 9 M119 SV guided missile, additional armor including 20 ohm of applique copyright armor in the front of hull, improved 840 HP engine. Note, despite popular belief the T-90 is not a modified version of the T-72. But they do share some characteristics. The T-72 design has been further developed into the following new models: Lion of Babylon tank, M84, M95 Degman, M2001, PT91 Twiddy, Tank X, and TR-125. Operators and variants. The T-72 hull has been used as the basis for other heavy vehicle designs, including the following: BMPT, a Euro heavy convoy and close tank support vehicle. TOS-1, a Euro thermobaric rocket launcher, with 30-tube launcher in place of the turret. BREM-1, a Euro armored recovery vehicle with a 12-ton crane, 25-ton winch, dozer blade, towing equipment, and tools. IMR-2, a Euro combat engineering vehicle with an 11-ton telescoping crane and pincers, configurable dozer blade plow, and mine-clearing system. MTU-72, a Euro armored bridge layer, capable of laying a 50 AT capacity bridge spanning 18 am in 3 minutes. Design characteristics. The T-72 shares many design features with other tank designs of Soviet origin. Some of these are viewed as deficiencies in a straight comparison to NATO tanks, but most are a product of the way these tanks were envisioned to be employed, based on the Soviets' practical experiences in World War II. Weight. The T-72 is extremely lightweight, at 41 tons, and very small compared to Western main battle tanks. Some of the roads and bridges in former Warsaw Pact countries were designed such that T-72s can travel along in formation, but NATO tanks could not pass at all, or just one by one, significantly reducing their mobility. The basic T-72 is relatively underpowered, with a 780 HP supercharged version of the basic 500 HP V12 diesel engine block originally designed for the World War II era T-34. The 0.58 am wide tracks run on large diameter road wheels, which allows for easy identification of the T-72 and descendants. The T-72 is designed to cross rivers up to 5 am deep submerged using a small diameter snorkel assembled on site. The crew is individually supplied with a simple rebreather chest pack apparatus for emergency situations. If the engine stops underwater, it must be restarted within 6 seconds, or the T-72's engine compartment becomes flooded due to pressure loss. The snorkeling procedure is considered dangerous but is important for maintaining operational mobility. Nuclear, biological, and chemical protection. The T-72 has a comprehensive nuclear, biological, and chemical protection system. The inside of both hull and turret is lined with a synthetic fabric made of boron compound, meant to reduce the penetrating radiation from neutron bomb explosions. The crew is supplied clean air via an extensive air filter system. A slight overpressure prevents entry of contamination via bearings and joints. Use of an autoloader for the main gun allows for more efficient forced smoke removal compared to traditional manually loaded tank guns, so NBC isolation of the fighting compartment can, in theory, be maintained indefinitely. Exported T-72s do not have the anti-radiation lining. Interior: like all Soviet legacy tanks, the T-72's design has traded off interior space in return for a very small silhouette and efficient use of armor, to the point of replacing the fourth crewman with a mechanical loader. The basic T-72 design has extremely small periscope viewports, even by the constrained standards of battle tanks, and the driver's field of vision is significantly reduced when his hatch is closed. The steering system is a traditional dual-tiller layout instead of the steering wheel or steering yoke common in modern Western tanks. This setup requires the near-constant use of both hands, which complicates employment of the 7-speed manual gearbox. There is a widespread Cold War-era myth that T-72 and other Soviet tanks are so cramped that the small interior demands the use of shorter crewmen, with a maximum height set at 1.6 am in the Soviet Army. According to official regulations, however, the actual figure is 1.75 am. Armor protection of the T-72 was strengthened with each succeeding generation. The original T-72 turret is made from conventional cast armor. It is believed the maximum thickness is 280 mm, the nose is about 80 mm and the glacis of the new laminated armor is 200 mm thick, which when inclined gives about 500 to 600 mm thickness along the line of sight. Late model T-72s feature composite armor protection. The T-72A featured a new turret with thicker but nearly vertical frontal armor. Due to its appearance, it was unofficially nicknamed Dolly Parton armor by the U.S. Army. The cast steel turret included a cavity filled with quartz or sand. The T-72M featured a different armor protection compared to the T-72A. It had a different composite insert in the turret cavity which granted it less protection against heat and armor-piercing munitions. The modernized T-72M1 featured an additional 16 mm of armor on the glacis plate, which produced an increase of 32 mm horizontally against both heat and AP. It also featured a newer composite armor in the turret with pelletized filler agent. Several T-72 models featured explosive reactive armor, which increased protection primarily against heat-type weapons. Certain late-model T-72 tanks featured heavy ERA to help defeat modern heat and AP against which they were insufficiently protected. Late-model T-72s, such as the T-72B, featured improved turret armor, visibly bulging the turret frontal nicknamed Super Dolly Parton armor by Western intelligence. The turret armor of the T-72B was the thickest and most effective of all Soviet tanks. It was even thicker than the frontal armor of the T-80B. The T-72B used a new reflecting plate armor, in which the frontal cavity of the cast turret was filled with a laminate of alternating steel and non-metallic layers. The glacis was also fitted with 20 mm of applique copyright armor. The late production versions of the T-72 bytes per byte 1 and T-72A variants also featured an anti-radiation layer on the hull roof. Early model T-72s did not feature side skirts. Instead, the original base model featured gill or flipper-type armor panels on either side of the forward part of the hull. When the T-72A was introduced in 1979, it was the first model to feature the plastic side skirts covering the upper part of the suspension, with separate panels protecting the side of the fuel and stowage panniers. The July 1997 issue of Jane's International Defense Review confirmed that after the collapse of the USSR, US and German analysts had a chance to examine Soviet-made T-72 tanks equipped with Contact 5 ERA, and they proved impenetrable to most modern US and German tank projectiles. This sparked the development of more modern Western tank ammunition, such as the M829A2 and M829A3. Russian tank designers responded with newer types of reactive armor, including Relikt and Cactus. Estimated protection level. The following table shows the estimated protection level of different T-72 models in rolled homogeneous armor equivalency. That is, the composite armor of the turret of a T-72B offers as much protection against an APF-SDS round as a 520 mm thick armor steel layer. Gun. The T-72 is equipped with the 125mm 2A46 series main gun, a significantly larger caliber than the standard 105mm gun found in contemporary Western MBTs, and still slightly larger than the 120mm per liter 44 found in many modern Western MBTs. As is typical of Soviet tanks, the gun is capable of firing anti-tank guided missiles, as well as standard main gun ammunition, including heat and APF-SDS rounds. The main gun of the T-72 has a mean error of 1 am at a range of 1,800 am. Its maximum firing distance is 9,100 am, due to limited positive elevation. The limit of aimed fire is 4,000 am. The T-72's main gun is fitted with an integral pressure reserve drum, which assists in rapid smoke evacuation from the bore after firing. The 125mm gun barrel is certified strong enough to ram the tank through 40 cm of iron-reinforced brick wall, though doing so will negatively affect the gun's accuracy when subsequently fired. Rumors in NATO armies of the late Cold War claimed that the tremendous recoil of the huge 125mm gun could damage the fully mechanical transmission of the T-72. The tank commander reputedly had to order firing by repeating his command, "When the T-72 is on the move, fire! Fire!" The first shout supposedly allowed the driver to disengage the clutch to prevent wrecking the transmission when the gunner fired the cannon in the second order. In reality, this still common tactic substantively improves the tank's firing accuracy and has nothing to do with recoil or mechanical damage to anything. This might have to deal with the quality of the T-72 stabilizers. The vast majority of T-72s do not have FLIR thermal imaging sights, though all T-72s possess the characteristic lunar infrared illuminator. Thermal imaging sights are extremely expensive, and the new Russian FLIR system, the Buran-Catherine thermal imaging suite, was only introduced recently on the T-80UM tank. Most T-72s found outside the former Soviet Union do not have laser rangefinders. T-72 built for export have a downgraded fire control system. Autoloader. Like the earlier domestic use-only T-64, the T-72 is equipped with an automatic loading system, eliminating the need for a dedicated crew member, decreasing the size of the tank, and hence the mass. However, the autoloader is of noticeably different design. Both the T-64 and T-72 carry their two-section 125mm ammunition in separate loading trays positioned on top of each other. But firstly, in T-64, 28 of these were arranged vertically as a ring under the turret ring proper, and were rotated to put the correct tray into position under the hoist system in the turret rear. This had the disadvantage of cutting the turret off from the rest of the tank, most notably, the driver. Accessing the hull required partial removal of the trays. T-72 uses a design that has lower width requirements, and does not isolate the turret compartment. The trays are arranged in a circle at the very bottom of the fighting compartment. The payoff is the reduction of the number of trays to 22. The second difference was that in the T-64 the trays were hinged together and were flipped open as they were brought into position, allowing both the shell missile and propellant charge to be rammed into the breech in one motion. In T-72 the tray is brought to the breech as is, with the shell in the lower slot and the charge in the upper one, and the mechanical rammer sequentially loads each of them, resulting in a longer reloading cycle. The average rate of fire for this type of carousel automatic loader is quoted to be 6 to 8 rounds per minute. The autoloader system also includes an automated casing removal mechanism that ejects the propellant case through an opening port in the back of the turret during the following reload cycle. The autoloader disconnects gun from the vertical stabilizer and cranks it up 3 degrees above the horizontal in order to depress the breech end of the gun and line it up with the loading tray and rammer. While loading, The gunner can still aim because he has a vertically independent sight. With a laser rangefinder and a ballistic computer, final aiming takes at least another 3 to 5 seconds, but it is pipelined into the last steps of auto-loading and proceeds concurrently. In addition to the 22 auto-loaded rounds, the T-72 carries 17 rounds conventionally in the hull, which can be loaded into the emptied autoloader trays or directly into the gun, slowly and awkwardly, due to the absence of a human loader. Service. The T-72 was never used in the Afghanistan War. The 40th Soviet Army that was deployed there had only T-55 and T-62 tanks. The Russian Federation has over 5,000 T-72 tanks in use, including around 2,000 in active service and 3,000 in reserves. The T-72 has been used by the Russian Army in the fighting during the First and Second Chechen Wars and the Russo-Georgian War. The T-72 has been used by over 40 countries worldwide. Syria. In the 1982 Lebanon War, Syrian T-72s engaged Israeli M60A1 and probably Merkava tanks in the south of Lebanon. On June 9, 1982, the Syrian General Headquarters ordered a brigade of the 1st Armored Division, equipped with T-72 tanks, to move straight ahead, cross the border, and hit the right flank of the Israeli units advancing along the eastern side of Baqir. The T-72s clashed with several companies of M60s, destroying some Israeli companies in process while suffering only a few losses in exchange. After the end of the ceasefire, Syrian T-72s continued to be used and destroyed several Israeli tanks and armored vehicles. Syrian and Russian sources claim that the T-72 had success against the latest Israeli Merkava tanks and that no T-72s were lost. Others claim that the two tanks never met in combat and that 11 to 12 T-72s were lost mostly due to anti-tank ambushes and the usage of tow missiles. 105 mm guns failed to penetrate the frontal armor of the Syrian T-72s. Only in one case the frontal hull armor was penetrated by a tow missile. According to some unofficial sources, one Syrian T-72 was knocked out by Israeli tank fire. However, according to official figures, no Syrian T-72s were lost due to Israeli tank fire. After the war, Syrian President Hafez al-Assad called the T-72 the best tank in the world. Iraq. The Iraqi T-72s performed well against opposing Iranian tanks such as Chieftains and Pattons in the Iran-Iraq War. In the early stages of the war, an Iraqi battalion of T-72 tanks faced an Iranian battalion of Chieftain tanks. During the battle all Iranian tanks were destroyed, while the Iraqis suffered no losses. Iraqi T-72 had great success in the battle for Basra and the last stages of the war. 105 mm M60A tank guns and tow missiles proved ineffective against the frontal armor of Iraqi T-72s. 60 T-72 tanks were lost during the 8 years of war. According to Iranians and Iraqis, the T-72 was the most feared tank of the Iran-Iraq War. The Iraqi-assembled T-72 version Lion of Babylon engaged Western forces in both Iraq wars. Battle of 73 Easting took place during a sandstorm in the Kuwaiti desert. American M1A1S and Bradley fighting vehicles came up against Iraqi Republican Guard T-72s and BMPs. The primary battle was conducted by two ACR's-3 squadrons of about 400 soldiers, along with the 1st Infantry Division's two leading brigades, who attacked and destroyed the Iraqi 18th Mechanized Brigade and 37th Armored Brigade of the Tawak-Alma Division, each consisting of between 2,500 to 3,000 personnel. On February 26, 1991, the Iraqis dug in T-72 tanks to stop the advance of American tanks in southern Iraq during the Battle of Faisline Bullet. Chechen Wars. During the First Chechen Campaign, Russia used 225 T-72 and T-80 tanks. The Cobra tank-launched missiles were used, which effectively destroy targets at a range of 4 kilometers. During the 3 months of fighting, 15 T-72B and about 5 T-72A were destroyed. In all cases, the tanks were destroyed when hit in the side or on the top. The frontal armor was never penetrated. Dudaev's forces had dozens of T-62 and T-72 tanks. In the summer of 1994, Russian aircraft destroyed about 15 of Today's tanks. After the assault by the Russian army during the winter of 1994, Today's last 30 tanks were destroyed or captured. 7 captured T-72s were used in combat by the Russian army. During the First War, at least 2 tank duels took place. In the first one, Today's T-72A knocked out one T-62M belonging to pro-Russian Chechens. In the second duel, one of Today's T-72s was destroyed by a Russian T-72B. From 1997 to 2003, Chechen rebels managed to destroy only 3 Russian T-72s, including only 1 tank during the Second Chechen Campaign. War in South Ossetia. During the war, Russia lost 2 T-72B tanks. In one case, a platoon of 4 Russian T-72s destroyed more than 15 Georgian armored vehicles on the streets of Tskanvoli, while losing 1 tank. During the 5 days of war, about 80 Georgian T-72 tanks were destroyed or captured, including most of the Israeli modifications T-72 SIM. Further service. In January 2009, it was reported that the Iraqi government was negotiating a deal to purchase up to 2,000 T-72 tanks. The T-72s were to be rebuilt and modernized. In September 2009, it was announced that Venezuela was planning to purchase 92 Russian T-72B1V tanks. The first T-72s destined to Venezuela arrived at the port of Puerto Cabello on May 25, 2011. In June 2012, Russia and Venezuela agreed on a deal for 100 more T-72B1 versus. Zhu Binshi, a high-ranking Chinese military engineer, revealed during an interview that China first obtained a T-72 from Romania in the 1980s, in exchange for plasma spray technology. During the Syrian civil war, government forces used T-72s among other armored vehicles against the opposition forces. Initially, the insurgent forces were forced to use IEDs and RPG-7 ambush tactics against the government armored forces. Later, modern Russian RPGs and Yugoslav M79 OSAs were recorded in rebel hands and being used to get successful hits on T-72s. Starting in 2012, the delivery and capture of modern anti-tank guided missiles enabled the opposition forces to successfully engage and destroy any government armored vehicle types, T-72 included, from safer distances. Combat history. 1980 Euro 1988 Iran Euro Iraq War, 1982 Lebanon, 1983 Euro 2009 Sri Lankan Civil War, 1988 Euro 1994 Nagorno-Karabakh War, 1988 Euro 1993 Georgian Civil War, 1991 Euro 1992 War in South Ossetia, 1992 Euro 1993 War in Abkhazia. 1992 to 1997 Civil War in Tajikistan, 1990 Euro 1991 First Persian Gulf War, 1990 Euro 2002 Sierra Leone Civil War, 1991 Euro 2001 Yugoslav Wars, 1991 Ten-Day War, 1991 Euro 1995 Croatian War of Independence, 1998 Kosovo, 2001 Macedonia conflict. 1994 Rwanda Civil War, 1994 Euro 1996 First Chechen War, first known case of using tank-launched missiles, which effectively destroy targets at 4 km range. 1999 Euro 2009 Second Chechen War, 2003 Invasion of Iraq, 2008 War in South Ossetia, 2011 Libyan Civil War, 2012 Syrian Civil War, government forces using T-72 tanks. Opposition forces using captured regime tanks, 2013 South Sudanese conflict, 2014 conflict in Ukraine, 2014 Northern Iraq offensive, see also. Comparable AFVs, Chieftain tank, related lists, list of tanks, list of Soviet tanks, 125 mm smoothbore rounds, 88 Songster, notes. References. External links, Vasily Fofanov's Modern Russian Armor page, huge pile of Hungarian T-72 walkarounds, T-72 variants, http:// www.Unitisk Military Tank T-72 HTML